Warm greetings everyone. This is our team and we are here to explain the enhancing IoT from 6LoWPAN to 6LO. The Internet of Things has revolutionized the way devices communicate and interact with each other, leading to a more connected and efficient world. One of the key challenges in IoT is ensuring efficient communication between devices, especially considering the diversity of devices and the constraint they operate under, such as limited power, memory, and bandwidth. In this exploration, we delve into the evolution of application transport methods from 6LoWPAN to 6LO, aiming to enhance efficiency in IoT networks. From here, they will be explaining about the challenges and the applications that are in enhancing the 6LoWPAN to the 6LO.
I am Dev here to present challenges in IoT communications, interoperability, ensuring seamless communication among diverse IoT devices with different protocols, security and scalability. Many IoT devices have limited processing power, memory, and energy resources, making it challenging to implement complex communication protocols and security measures while maintaining effective operations. The third point is resource constraints, keeping IoT network safe from attacks and handling more data traffic while making sure everything runs smoothly. The next topic is advantages of 6LoWPAN. IPv6 compatibility enables IPv6 communications over low power wireless networks, ensuring compatibility with existing internet protocol and infrastructures. Interoperability facilitates seamless integration of IoT devices with IP-based networks, allowing them to communicate directly using standard internet protocols. Scalability supports the scalability of IoT network by enabling a large number of devices to connect and communicate efficiently within the IPv6 address space. Resource efficiency optimized the use of network resources, conserving battery life and reducing communication overhead in resource-constrained IoT devices. Simplified development simplifies the development and management of IoT networks by leveraging familiar IPv6 networking principle and tools. Securities providing support for IPv6 security mechanisms, enhancing the overall security postures of IoT deployments. So the next topic is the difference between 6LoWPAN and versus 6LO. Features protocol 6LoWPAN IPv6 over low power wireless personal area network, and the next side is 6LO IPv6 over network. Use case specifically designed for low power, low bandwidth wireless network commonly used in IoT devices. 6LO generally used for IPv6 over various network. Efficiency optimize network resources for resource constrained IoT devices. 6LO provides flexibility for IPv6 deployment over different network types, addressing supports efficient address compressions for reduced overheat. 6LO supports IPv6 addressing without compression. Security generally supports standard IPv6 security mechanisms. 6LO generally supports standard IPv6 security mechanism. Scalability facilitates scalability of IoT networks by enabling a large number of devices to connect efficiently. 6LO supports scalability of IPv6 network but may not be optimized for low power, low bandwidth network.
From here onwards, I'm going to take the presentation, the implementation of 6LO in IoT systems. In that, there are 5 types of there. Before that, I'm going to tell about the implementation of 6LoWPAN. The IPv6 over low power wireless personal area network in IoT systems involves the adapting IPv6 interneting protocol to accommodate the constraints of low power and the resource constraint of IoT devices. Here, briefly overview the 5 points. What are the 5 points? Means the efficient addressing and the addresser compressions and the fragment and reassembly and the mesh networking and the interoperability. And the first one is the efficiency addressing. The 6LoWPAN follows to IoT devices to use IPv6 addresses and enabling direct communications over the network and integration with existing IPv6 networks. And the second one is the header compressions. in the header compressions to minimize the overhead, and the 6LoWPAN employs the header expression techniques and reducing the size of IPv6 and the UDP headers for efficient uses of bandwidth. And the third one is the fragment and the reassembly. In that, the large IPv6 pockets are fragmented into smaller units to fit within the constraint of low power networks. And these fragments are then reassembled at the destination. And the fourth one is the maze networking. The 6LoWPAN supports the formation of maze networks, and where devices can relay data to extend the coverage and improve the reliability, and the essential for IoT deployments spanning larger areas. And the last one is interoperability. By implementing 6LoWPAN, the IoT devices can seamlessly communicate with other IPv6 enabled devices and services. Future trends in IoT communication. The several future trends are shaping the landscape of IoT communication and paving the way for more efficient, reliable, and secure connectivity. And the future trends in IoT communication, an examine of emerging trends and the innovations in IoT communications, with a focus on the evaluation of application transport methods, and the advance with and shape the future of IoT efficiency. And then finally, we are in conclusion. In conclusion, the enhancing IoT efficiency through application transport methods and transferring from the LoWPAN to 6LoW, the IPv6 over constrained networks, and offering a comprehensive approach to optimize communication protocols for resource constrained IoT devices. And by exploring the implementation of application transport methods from 6LoWPAN to 6LoW, the IoT systems can enhance efficiency, reliability, and the interoperability, and paying a reboost foundation for the future growth and the innovation of IoT deployments. And then finally, this presentation is done by myself, Vishal, and Dev. Thank you.